This video is going to be a little bit different than the other videos. It contains some examples to practice on integration, and the idea is that you work with me on this one. So when I put a question up, I suggest you pause, try it yourself, and then see if we get to the same answer. I'm not going to go too deep into the explanations. The other videos are there for explaining how we integrate. So these are just practice ones for you to test how you're doing. So work with me on these ones. So here we go. It's also going to be a bit longer than normal, but the idea is that this is a working project. So here we go. The first two integrals. So in the first one, if we see a root, it's sometimes easier just to write it as x to the power 1 over 5. Because then we can see what to do with it. The rest we don't need to change, because then we can use our integration rules. There's no need for any substitution or any other techniques here. We're simply using our basic rules of integration. So it's x to the power 1 over 5. If we add 1 to the exponent, it's 6 over 5. So we've got 5 over 6 x to the power 6 over 5. Plus the antiderivative of 4 to the power x is 4 to the power x over ln 4. Now there's a minus 3 sine x. Now the antiderivative of sine x is minus cos. So I've got a minus is already there, so it's plus 3 cos x. Now if you're wondering if your sign is right and you're doubting it a little bit, then take the derivative. The derivative of 3 cos x is 3 times minus sine x, and that gets me back to what I had there. 2 pi, I threw a pi in there just to make sure you notice. Pi is just a number. So this is similar. This is a constant. So the antiderivative is just the constant times x. And don't forget your integration constant. So this was a straightforward one. No integration techniques required. Let's look at the second one. Now you've got two options for this one. If you've done a lot of integrals, you can do this one in one step. But I'm going to do it with a substitution. You can see what the answer is and see if you get there. But first try it yourself. I'm going to say let u be equal to 3x minus 7. du is then 3 dx. I don't have a 3 dx there. I just have a dx there. So that's a third du. So I'm going to make my substitution. That is a third times the integral of e to the u du. Now the integration is very quick and easy. The antiderivative of e to the power u is just e to the power u. And we have to go back to x because the original question was an x. So that's 3x minus 7. So if you do not want to do it with substitution, that's fine. If you're confident with your integration techniques, what you just need to see is the derivative of that numerator is just going to be 3. So we need to compensate for that with the third. But if you don't like it, you'd rather systematically do it, then use substitution. Here are the next two. Cos of 6x dx. Yet again, you can do it in one step or you can use substitution. Try it yourself and then let's see. If you do it with substitution and you let u equal to 6x, then du is 6 dx and 1 over 6 du is then dx. So I've got 1 over 6 times the integral of cos of u du. And the antiderivative of cos of u is sine of u. So it's 1 over 6 sine of u plus c, which gives me 1 over 6, always go back to x, sine 6x plus c. So it's another example that you could have done without substitution if you've done a lot of them. But if you're a bit hesitant still, there's nothing wrong with doing substitution. All right, let's look at the next one. Now we know the derivative of tan of x is sec squared x. But we don't have a shortcut for the antiderivative of tan because there's none of the trig functions gives me a derivative of that is tan of x. So we've got to work a little bit. Now, thankfully, we know that that is sine of 6t over cos of 6t dt. Now we're going to have to do a substitution, but you've got to choose the right one. So if I let u be equal to sine of 6t, my derivative of cos isn't there. There is a cos, but it's 1 over cos. It's in the denominator, so that's not going to work. So I'm going to say let u be equal to cos of 6t, because its derivative is there in one form or in the other. We've got the sine of 6t. So du, the chain rule tells me that is minus sine of 6t times the derivative of 6t, which is 6 dx. So it's minus 6. So I've got minus 1 over 6 du is then sine of 6t. Did I say dx? I meant dt. There we go. I've got a sine 6t dt there, so I can do my substitution. That's minus 1 over 6. The integral of sine 6t dt is the minus 1 over 6 du, so I've got 1 over u du. There we go. Now we've simplified it. The antiderivative of 1 over u is ln of the absolute value of u. So that's minus 1 over 6 ln of the absolute value of u plus c. So this is then minus 1 over 6 ln of u. U is cos of t, so it's the absolute value of cos of 6t plus c. Here's the next two. Give them a try. And then see if we've got the same answers. All right, in the first one, we'll need a substitution again. If I look at this function, 4x squared minus 2, its derivative is present. The derivative is 8x, but I've got the x, and we don't worry about the 8. We know we can figure that one out. So I'm going to let p be equal to 4x squared minus 2. dp is equal to 8x dx. I've only got an x dx, but that's not a problem because that's 1 over 8 dp, and we can make our substitution. Now, I used p instead of u because it gets very boring using u all the time, but it's just a placeholder, that's substitution, so you can use any variable that's not present in the original question. So that is 1 over 8 times the integral. X dx is there, cos, and I've got cos of p dp. Antiderivative of cos is sine, so it's 1 over 8 sine of p plus c, and that's 1 over 8 sine of 4x squared minus 2 plus c. All right, the next one is going to take a bit of thinking. We've got sine of log x divided by x. Now, log x we know is close to ln x, but it's not ln x. But we also know what the derivative of any log base a is. Now, there's two ways of doing it. You can first rewrite it as ln and then take the derivative, or you can remember what the derivative of log of x is. So, I'm going to say let u be equal to log of x. Now remember, this log is the natural common logarithm, not the natural, the common logarithm, so it's a base 10. So if you know your logarithmic differentiation, du is then the derivative of log of x, log base 10, is the same as 1 over x ln 10. All right. Now, if you don't know that, there's a different way you can do it. If u is log base 10 of x, it's the same as ln of x over ln of 10. So that's the same as 1 over ln 10 times ln of x. And now if I want du, and not forgetting the differential dx, it's 1 over ln 10 times the derivative of ln x is 1 over x, so it's 1 over x dx. So we get the same answer. So whichever way you do it, you get there. Now, why did I let u equal to log of x? Because I've got the 1 over x is here in some form. So, only problem is, there's that ln 10. How do I get rid of it? Well, multiply both sides. So, ln 10 times du is 1 over x dx. And that's what I've got, 1 over x dx. So, this integral is then ln 10 times the integral of sine of u. The 1 over x dx becomes the ln 10 du. There we go. Simplified this one that looked a bit messy. So that's ln 10. What's the antiderivative of sine of u? That's minus cos of u. So I've got minus ln 10 times cos of u, which is log of x, plus c. There we go. Next two. Again, we're going to use substitution. Now, all these integration examples, we go as far as using substitution as an integration technique. The other integration techniques come later. All right, so sine of x times e to the power cos x. Yet again, we're looking for a function and its derivative present. But we can see the derivative of cos x is there in the form of sine of x. Now, the derivative of sine of x is not there because the cos x is as an exponent. So I can't take it away from there. I can't take it out. So I have to let u be equal to cos x. du is then minus sine x dx. Now I only have a sine x, but that's easy to compensate for. Minus du is then sine x dx. So let's take a look. This is then minus the integral. That sine x dx gets swallowed up, and I've got e to the power u du. And that we know is nice and easy to integrate. That's minus e to the power u plus c, which is minus e to the power cos x plus c. And remember, with all of these, you can always differentiate to test your answers. So if we look at this one, where there's an x squared, there's a 2x cubed minus 9. If I look at this function in the denominator under the root, the derivative of 2x cubed is 6x squared. Now I don't have the 6, but I've got the x squared, so that's good enough for me. So there, let u be equal to 2x cubed minus 9. du is then 2 times 3, which is 6x squared dx. Now I only have an x squared dx, but that's fine. That's 1 over 6 du. So once we do our substitution, that's 1 over 6 times the integral of the x squared dx gets swallowed up by the 1 over 6 du. So it's 1 over the root of u du. Now I'm going to write that as an exponent, so we can use our laws. That's u to the power minus a half. So the antiderivative of u to the power minus a half, we need to add 1 to the exponent, so it becomes positive a half. 1 divided by positive a half is 2. U to the power a half plus c. So that gives me 1 over 3, and u is 2x cubed minus 9 to the power a half plus c. Now, whether you write it like that or with the square root, it means the same thing. All right, here's the next two. Give them a try and see how it goes. Okay, here I've got a sec squared. Now we know the antiderivative of sec squared is tan, so we'd like to keep the sec squared there. The derivative of sec squared is not so simple. Let's look at the other functions. I've got an x minus 2 and a 2x squared minus 8x. Now if I look at the 2x squared minus 8x, du is then 4x minus 8 dx. Now I don't have a 4x minus 8, but I've got an x minus 2. So I can take a 4 out, that's x minus 2 dx. There we go. So 1 over 4 du is x minus 2 dx. So we can make our substitution. That's 1 over 4 times the integral. The x minus 2 dx gets swallowed up in the quarter du. So it's sec squared u du. And then we know we've got 1 over 4 tan of u plus c. So that's 1 over 4 tan of 2x squared minus 8x plus c. All right, next one, substitution again. If I look at that exponent, is its derivative present? Yes, there's an x. The constant we can figure out. So if I say let p be equal to minus 4x squared minus 2. dp is then minus 8x dx. Now I've got a x dx, so that's good enough. Minus 1 over 8 dp is then x dx. So that is minus 1 over 8 times the integral. The x dx gets swallowed up by the minus 1 over 8 dp. So I've got e to the power p dp. Yet again, we love that one because we love integrating e. That's e to the power p plus c. So that gives us 1 over 8 e to the power minus 4x squared minus 2 plus c. All right, that gets us to some inverse trig functions. So if you've worked with inverse trig functions, this one's for you. If you're not familiar with inverse trig functions, then this is not going to work. If we look at this format, this should ring a bell. You should remember that the integral of 1 over 1 plus t squared dt is arctan of t plus c. So that's inverse tan. So that's the format we have. Now I don't have it in that format. I need 1 plus something squared. But it looks like we can get it in that format. That's the same as the integral of 1 over 1 plus, that's just 3x squared. All right, so now we're better. But now I want that to be just my variable, so I will need to do a substitution. So if I say let t be equal to 3x, dt is then 3 dx. And yet again, whether I use a p or a u or a t, as long as I use something else that's in there, doesn't matter. I just have a dx, so dx is then a third dt. So when we make our substitution, we've got a third times the integral of 1 over 1 plus t squared dt. So that gives us a third arctan of t plus c. So that's the third arctan of 3x plus c. There we go. This is another inverse trig one, but it works a little bit differently. But yet again, hopefully you remember that the integral of 1 over the root of 1 minus t squared dt, that's arcsine of t. So inverse sine function. All right. So now I've got the square here, but I've got a 16. I need a 1. So what are we going to do? That's the integral of 1 over the root of. If I take 16 as a common factor, I've got 1 minus x squared over 16. Now we've messed up that one, but we'll get there. We first fix the 1. So the root of 16 is 4. So that's the same as the integral of 1 over 4 times the root 1 minus. Now x squared over 16 is just x over 4 squared dx. All right. So now that 4 I can take out. Now let us turn that into a variable. So if I say let u be equal to x over 4, du is then 1 over 4 dx. I actually have a 1 over 4 dx, but if you didn't notice that, then you can say 4 du is dx. So I replace the dx by a 4 du, so I'll multiply that with 4, the integral of 1 over the root of 1 minus u squared du. And that gets it into the format for arcsine. Quarter times 4 is 1, that's very nice. And the antiderivative of 1 over the root of 1 minus u squared is arcsine u plus c. So that is just arcsine or sine inverse of x over 4 plus c. So those are the inverse trig functions. Now we're going to look at some questions that are posed as multiple choice questions, just so that you can look out for the kind of things that can come with multiple choice questions and not get confused by the decoys. So here we go. Here is the question. The integral of 2x to the power 4 divided by the cube root of x to the power 5 plus 1 is equal to. Now, if you look at the possible answers, we didn't ever integrate. The final answer is not there. So this looks like a substitution happened. So we have to do a substitution to see if we can get to something similar. So if we had to integrate that, if we've got the integral of 2x to the power 4 over the cube root of x to the power 5, so x to the power 5 plus 1 to the power 1 over 3 dx. The derivative of x to the power 5 plus 1 is present in the x to the power 4. So if I say let u be equal to x to the power 5 plus 1, du is then 5x to the power 4 dx. Now I've got an x to the power 4 dx, so that's 1 over 5 du. So this will become, this 2 I'm taking out because it's a constant, times 1 over 5, so 2 over 5, the integral of the x to the power 4 dx gets swallowed up, so it's 1 over u to the power a third du. So that's 2 over 5, integral of u to the power minus a third du. So we just add 1 to the exponent, so it's 2 over 5. Now minus 1 over 3 plus 1 is then 2 over 3, so it's 3 over 2. Now I'm integrating, but anyway, u to the power 2 over 3 plus c. But now if I get back to my possible questions, I didn't have to integrate. I knew that when I started. So the question is, which one of these is it? 2 over 5, integral of u to the power minus 1 over 3. So there is our correct answer. All right, next one. The integral of sine 2 cos x dx. Now, the thing here to watch out for is, do you recognize that sine 2 is a constant? So keep in mind that sine 2 is a constant and then see what answer are you going to get to if you do that integral. So the fact that sine 2 is a constant means that's the same. This is just a constant. So the only variable is the cos x with a variable is cos x dx. So I can take the sine 2 out as a constant times the integral of cos of x dx. Now what's the antiderivative of cos? That's sine of x plus c. Now is it positive sine of x? Yes, because the derivative of sine is cos. There we go. So we've got sine 2 times sine x plus c, which gets us to that second one. So the thing to remember is, don't get confused and think sine of 2 is a function. It's simply a constant function, so it's just a constant. All right, here's the next one. Now this is a definite integral. So let's just look at what's asked. The integral from 0 to 3 of sine of 4x plus 2 dx. Now we see all our answers again are still in integration. We haven't integrated yet. It's simply a substitution that happened. So let's do this one and looking at the substitution. So if we look at the integral from 0 to 3 of sine of 4x plus 2 dx. Now all of these are sine of u. So that tells you already what your substitution is going to be. So if u is equal to 4x plus 2, du is 4 dx. I only have a dx, so dx is 1 over 4 du. So that already helps. Now, don't make the mistake of looking at the answers and seeing which one looks the closest and just picking that one. Follow through with the question. What you need to remember with a definite integral is these limits of integration refers to the variable x. We are changing our variable to u, so my limits of integration also changes. So if x is equal to 0, that means u is going to be 4 times 0 plus 2. U is 2. If x is equal to 3, u is 12 plus 2 is 14. So this becomes the integral from 2 to 14. There's the quarter. Sine u du. Is that option there? That option is definitely there, number C. All right, so when doing definite integrals, always remember to change the limits of integration. All right, now just two questions to look at areas bounded. I'm giving you the integral and I'm saying what area is bounded by this integral. All right, so there's a couple of things to look at and a couple of options. Now we know if I look at the area under a graph bounded by the x-axis, x squared plus 4. If I had to sketch x squared plus 4, it looks like this. That's 4, this is x squared plus 4. So if I look at the integral from 0 to 3, if I want the area, this area given here, that would be the area bounded by x squared plus 4, x equal to 0, x equal to 3, and the x-axis, or y equal to 0. Those are the boundaries, the 4 boundaries of that area. So let's see if that is present. All right, all of these first 3 only have x squared. Here's the function x squared plus 4, x equal to 0, x equal to 3. But I've got the y-axis there. I don't have the x-axis. Now, bounding it by the x-axis means it cuts it off there. So the y-axis just means it's x equal to 0 as well. So this is an unbounded area. This last one carries on and on and on and on forever. So we can't even calculate that. So it's not that one, even though that one looked close to correct. It's not correct because it's got the y-axis there, not the x-axis. So that's not going to work. So let's look at the area between two curves. If I have two curves, x squared, so let's say our one function is x squared, and our other function is either 4 or minus 4, because those are the two options that we're looking at now. All right, the answer could also be none of the others, but let's take a look at that. If I want the difference between, if I look at the functions 4 and x squared, if I want that area there will be the integral from here to here. Well, we're looking at the integral from 0 to 3, so whatever 0 and 3 is, that doesn't have to be that bounded area. But if I go from 0 to 3, 3 is over here somewhere. Well, then something weird's going to happen here. If I take the integral from 0 to 3 between x squared and 4, I've got a part that's positive, part that's negative. It's going to be a bit of a mess. Let's look at x squared and minus 4. X squared and minus 4. If I look at the area from 0 to 3, then if I look at that area, that will be represented by the integral from 0 to 3 of the function on top is x squared, so it's x squared minus the function at the bottom, which is minus 4. There we go. So that, if I look at the area between these two functions, x squared and minus 4, 0 and 3, x equal to 0 and x equal to 3, I've got it. So it's definitely not 4. It can't just be minus 4. It's got to be chopped off between 0 and 3. So there we go. That was a bit of work to get there, but that's what that integral represents. All right, so it's a bit more difficult if we're given the integral and we're trying to get to what it represents. Whereas the next question asked me for the area bounded between two functions. All right. If you look at the area bounded between two curves, you must be able to sketch the curves. X squared plus 1, that's 1. This is x squared plus 1. 4 minus x squared goes this way around. That's at 4. 4 minus x squared. Now I know that's minus 2 and 2, minus 2 and 2, but it doesn't really matter because I want the area bounded, so I want that area. So that area bounded is going to be the integral from, I need to find those limits, of the top function, which is 4 minus x squared, minus the bottom function, which is x squared plus 1 dx. All right. So let's take a look. What are these limits of integration? That's where the two functions intersect. So if I look at where is x squared plus 1 equal to 4 minus x squared, that's where 2x squared minus 3 is equal to 0. Or x squared is equal to 3 over 2, or x is plus or minus the root of 3 over 2. So this is minus the root 3 over 2 and plus the root 3 over 2. All right, this number C is starting to look very inviting. So let's take a look what happens if I simplify that. That's the integral from minus root 3 over 2 to positive root 3 over 2 of 4 minus 1 gives me 3, minus x squared is minus 2x squared dx. And that's exactly what we've got for number C. But don't jump to conclusions because that none of the above option could come into play. So follow through, finish it, and check that you've got the right answer. So I hope you were able to work with me here and you did not just watch me do examples, because there's a lot of videos on me just watching me do examples. So hopefully you were able to work with me and come to grips with all of these questions.